In this video, I will be explaining question number 1 of homework 11. So let's first look at question number 1. Question number 1 is that we are given xt, a real wide sense stationary process, and with autocorrelation r of tau and power spectral density sx of omega. We need to show that r of tau is real, autocorrelation is real and even, and also its power spectral density s of omega is even and non-negative. So let's look at the solution now. So the solution is we are given x of t is a real wide sense stationary process. So we can write its autocorrelation is equal to r of tau equals to r of t plus tau comma t. So we know as this is autocorrelation function, we can interchange the places of t and t plus tau. That's what exactly we do here, and write in terms of expectation, that is expectation of x of t comma x of t plus tau. Note that we have changed the position of t and t plus tau. So this can be written similarly to r of t comma t plus tau, and this is nothing but r of minus tau. So we see that rx of rxx of tau equals to rxx of minus tau. That means it's an even function. So it is proved. Now the second question is to show that the power spectral density s of omega is actually positive and it's also even, I guess. Let's see the question. Yeah, it's even and non-negative. So we know from the definition 0 less equals to s of omega, and so we just put the definition, that is we take the integration from minus infinity to plus infinity rx of tau into e raised to the power minus j omega tau d tau. So we just expand e in terms of cos and sine and get this value, that is integration of minus infinity to plus infinity rx tau into cos omega tau d tau minus j into j is constant, so we take it outside of integration, and so minus j into integration of minus infinity to plus infinity rx tau into sine omega t d tau. So we know that sine omega t is an odd function, so this actually, and rx tau is an even function, so this whole quantity rx tau into sine omega tau is actually an odd function. So if we take its integral from minus infinity to plus infinity, it will integrate to 0. So that's what we get, and put this value 0 here, and we get that. Also similarly, as cos omega t to cos omega tau is an even function and rx tau is an even function, so this whole quantity is an even function. So we can replace it, we can replace the integral from minus infinity to plus infinity by 2 into 0 to infinity. That's what we do here, 2 into 0 to infinity rx tau into cos omega tau d tau. Now we see that this is nothing but, as cos is an even function, we can also write it in terms of cos of minus omega tau. So if we write it as in terms of minus cos omega tau, we can similarly write it as sx of minus omega. So that means sx of omega equals to ss of minus omega, which proves that power spectral density is even and positive. So that's it for question 1.